Hello everyone, welcome to the Complete Python Beginner course. In this video, I'll be taking a complete beginner to programming, that is no previous programming experience, through everything you need to know about programming and Python as a beginner. When you start programming, you're likely to forget things. It's part of the process. To make things easier for you all, I'm going to be including a cheat sheet and a written version of this tutorial at the end of the video to help you quickly recall everything you learned today, as well as go back to any concept that you may have forgotten. I will also let you know the 7 problems that made me fall in love with programming and made it finally click for me after several failed attempts. With that, let's get started. We'll begin with a very quick brief on Python. So the language was released in 1991 and it was created by a guy named Guido van Rossum. It's used for a whole host of things, including machine learning and AI. This is actually one of the more prominent areas Python is being used today. It's also quite heavily used for data analysis and web scraping, as well as web development. It's very good for automation and scripting. I use Python quite a bit to automate my work or make it easier. Python is not usually the first choice for game development, but it's something you can do if you wanted to. And you can use it to build software. This is not an exhaustive list. There's a whole bunch of things you can do with Python, but this is some of the more common areas where it's used. Python is designed for readability, which is one of the things I love about the language. Because of this, it's very easy to get started with. From my personal experience, I find it really quick and easy to get up to speed with Python code that I haven't seen before. And finally, it's an interpreted language, which makes it quick for prototyping. Now, there are two main types of languages, compiled and interpreted. Types of languages can mean a whole number of things, but in this case, I mean how the computer runs your program. So, compiled languages are converted into machine code and stored on your computer as executables, the .exe files that you may have seen. When you run the executable file, that machine code is executed by your CPU. Interpreted languages are a little different. When you execute an interpreted language, a program called an interpreter reads your code line by line and executes it. So if this were Python code, the interpreter would read the first line, convert it into machine code, and then execute it. Then it would read the second line, convert into machine code, execute. Read the third line, convert into machine code, execute. This makes it slower than compiled languages because compiled languages have the whole program already converted into machine code. They are ready to run, but interpreted languages need to be read, understood, and executed. So that makes them slower than compiled languages. And because of this, you'll also often hear that Python is slow. However, as a beginner, do not worry about this. There's a reason Python is one of the most used languages in the world, in addition to being used by massive companies like Google, Microsoft, Facebook, Netflix, Intel, etc. And it's also the choice for data analysts and data science, including AI. So don't worry about the language being slow. It's not as big a deal as it's sometimes made to be. As a beginner, it is imperative that your focus is on building things in place of worrying about the fastest or best language. So don't worry about which language is the best or the fastest. Just learn the language and build stuff. Now that we have that out of the way, let's get our system set up to write some code. We need two pieces of software to write and run our Python code: a text editor where we write our code, and the Python interpreter which will run our code. Some modern systems come with the Python interpreter already installed, so we'll first check to see if it's already installed on our system. What I'm gonna do is open up command prompt. On Linux or Mac, you can use the terminal. You can also use the Windows terminal if you have that installed, but for simplicity I'll just use command prompt. So I'll open up start and type in cmd. That brings up command prompt. I'll run it. Now what we want to do here is type in python space dash dash version. So that's python space 2 dashes version and press enter. If you see something like this, python 3.12.2, that means Python is installed on your system. If however it's something like command not found or Python is not installed, then Python is not installed on your system and you'll have to go get it. Also ensure that you have 3.9 or higher. If you don't, you may wanna update. But yeah, to get Python, I'm going to go to Google and type in Python. We want the link that goes to python.org. So for me, that's this first one here. I'll click that. I'll go over to downloads. Since I'm on Windows, I'll come down to Windows and I'll click this button to download Python. When you click this button, it should start the download for you. Okay, there we go. Run the installer and you should be greeted with this screen. So here I'm going to check this box that says edit Python to path. This is important, and I'm going to choose customize installation. I'm going to leave everything as it is. Next. Now here you have a choice. The first option here says install Python for all users. If you have more than one user on your system and you want to install Python for them as well, you can check this box. If you just have one user account or you don't want to install Python for all users, then you can leave this unchecked. You can also change the location, the install location down here, and once you're ready you can click install. Give it a second to install, and once it's done installing, it should say setup was successful and we can close out of this window. Let's verify our Python installation. So I'm going to close out this old command prompt window. This is important, and I'm going to open up a new window. So start cmd and once again Python dash dash version, and you should see Python 3.12.2 or something similar. With that, Python is installed. Now let's get our text editor. For these sets of tutorials, I'm going to be using VS Code. It's one of the most popular options out there and it's pretty good. So I would recommend VS Code. To get VS Code, once again in Google, I'm going to type in VS Code. So VS space code. That should bring up this Visual Studio Code link. So I'm going to click that. And you can download it here. So VS Code is also available for Mac and Linux, so you should be good there. I'm gonna download the Windows version since I'm on Windows. Okay, and that should start the download for me. Once downloaded, run the installer and you should be greeted by a screen like this. So I'm gonna click on accept the agreement. You can go through the license terms. Next. Now create a desktop icon, that's up to you. For me, I'm going to check all these boxes. You can choose not to, that's up to you, but I personally like to have this. Basically what these allow me to do is if I right click a folder or a file, I'll have this option to open with code, and I work with VS Code a lot, so it's pretty handy to have that. That's for the first two options. Third one, you can leave that checked. Add to path, you can also leave that checked, that's also fine. First two is up to you, just right click. If you want that there, then it's pretty handy to have, so you can click next and install. I'm gonna cancel out of this because I already have it installed, but click install and that should install it on your system. Once done, you should have an icon on your desktop, or you can also find it in your start menu. So when you open VS Code, you should be greeted by a screen like this or something similar, and we have VS Code installed and working. Awesome. We are going to see how we can display stuff on the console window. To get started, I have VS Code open here, and I'm just going to create a new file. Choose text file if you get this, and then I'm going to go to file, save. Now you can save this wherever you like. I'm going to save it on my desktop as hello.py. The .py is important. It basically tells our computer and Python that this is a Python file. So I'm going to save it, and now in my file I'm going to type in print and open close parentheses, and then inside the parentheses I'm going to type in hello world inside double quotation marks. So once we have this, I'm going to go to file, save. You can also use Ctrl S, and then I'm going to open up my command prompt. You can use the terminal as well. Right, now my command prompt by default opens up in my account folder. Our file is stored on the desktop, so we need to change to the desktop. The way to do that is to type in cd space desktop and hit enter, and that takes me to the desktop. Now I can run the file. So I'll type in python space my file name, which is hello.py, and when I hit enter, we get hello world. Congratulations, you've just executed your first Python program. So this python hello.py, it's basically telling the Python interpreter to run the hello.py file. Now in the file we have one line of code, which is print hello world. Print basically tells Python to write something, to show something on the console window, and since we are telling it to print hello world, it displays hello world. We can use print however many times as we like, so I can just have 3, 4, 500 of these here, and when I run this, Python's going to run each of them. You'll see that we have empty lines in the file here, but not in our program. That's because Python ignores all white space, so all these empty lines will be ignored. It's just going to worry about what's inside the quotation marks in the print. Let's try something. Let's try doing print 2 plus 2. And when I run this, you see we get 2 plus 2. So it does not really do the calculation and give us 4. It just displays 2 plus 2. The reason for that is these quotation marks. Basically, these quotation marks tell Python to show this exactly as it is written. If I wanted to do the calculation 2 plus 2, then I would type that outside of the quotation marks. So something like this. And now when I run it, we get 4. And yep. Now we can also do something like this. Print. So 2 plus 2 equals 2 plus 2. And when I run this bit of code, I get 2 plus 2 equals 4. So here what I've done is I've basically combined an expression inside quotation marks with an expression that's not in quotation marks. You can do that with the comma. So you can have one expression, comma, another expression. And with that, you can have something like this, 2 plus 2 equals 4. You'll see that each print statement is printed on its own line. If you did not want to do that, if you wanted, let's say, this hello world to appear on the same line as the first one, then what I can do is, for my first print statement, I can do comma and equals and then empty quotation marks. And when I run that, we get hello world on the same line. Now you'll see that these two are scrunched in together. So let's say if I wanted a space here, then what I can do is just put a space in the end. Now when I run it, we get hello world space hello world. You can actually put whatever you like in this end here. And yeah, it's going to use whatever you type in as the separator between these two hello worlds. So in this case I typed in some gibberish, so that's why I was using that. So basically what the end does is it tells Python how to end this print statement. So by default, Python ends all print statements by moving the cursor to the next line. So it's going to display this and then move the cursor to the next line, which is why you were seeing hello world on two different lines earlier. It basically printed this, moved the cursor to the next line, so when the next print statement is executed, it prints on the second line, moves on the third line, then it prints the next one, and so on. By changing the end, we are telling print to end the line with something else. So in this case, it's ending with this gibberish. So what it essentially does is it prints hello world, then it puts the ending, whatever we gave it to end with, and then the next print statement basically prints out the second hello world, right? So that's how you can essentially tell Python not to move the cursor to the next line by using end. Now if we go back to what we printed earlier, you'll see that on this last line 2 + 2 = 4, there are two spaces after the equal signs, and that's because the comma actually puts in a space for us. So to get rid of that, we can essentially do this, remove the space from our quotation marks, and when we run it, you see that it's gone. Another thing you can do is, if I bring this back, I can actually just say comma SEP equals empty quotes, and now you'll see that we no longer have that second space. Once again, you can put whatever you like here, so I can just put like ... and you see we get ... So basically SEP tells Python what to use between the expressions before and after the comma. One thing to note, the end and the comma part needs to come after all these expressions, so it needs to be the last thing in your print statement, right? You can also combine these, so I can have sep and end, both of these together, as long as they appear as the last thing, as the last expressions in your print statement. Awesome. So one more thing before we end this video, I've used double quotes here, but in Python you can use either double or single quotes. So I could have also done this. So hello world in single quotes, and if I run this, we get hello world once again. Now it printed it on the same line as the 2 + 2 because of this end here, but that's okay. So yeah, in Python we can use either double or single quotes. You just need to ensure that you end with the one that you started out with, and good programming practice dictates that you stick to one. So you choose either double or single and use that throughout all your programs to be consistent. So consistency, that's good programming practice. Okay, cool. So that's all for this video. To recap, whenever you want to display something on the console, you use the print statement. You can use the end parameter. This is called a parameter. You can use the end parameter to say how the print statement ends. You can separate multiple expressions using the comma, and you can use either double or single quotes. So in the last video we checked out print. In this video we are going to talk about comments. Comments in programming are like notes. So basically your compiler, or in the case of Python, your interpreter, will ignore whatever comments you put in your code. The way to write a comment in Python is using the hash or the pound symbol. So basically, once I type in a hash, everything on that line from the hash onwards is ignored by Python. So I can just do a hash and type in some gibberish here. And if I run the code from the previous lesson, you'll see that nothing really happens for this line. We don't really see anything. Now I can also take this and put this after code. So when I do this, basically Python reads the line up to here, and since it encounters a pound symbol, it ignores everything from here on out. So if I run this, you see once again, we don't really get anything afterwards. Awesome. So what I'll do is I'll just copy this over. Let's clean the file up a bit. So I'll just do this. Okay. And I'll get rid of these as well. Okay. So let's comment out this line and see if Python does anything for us. Just to see something, let's put one before it as well. So essentially we should see two print statements, but if I run this, we get only one. Once again, that's because Python's going to ignore this line since we have commented it out. If I did this, yeah, we just get one, because once again, this part's not commented out, so it's going to execute, but since this part is commented out, it's going to be ignored. Now this is called a single line comment. Basically, if I wanted to create another comment on this line, I have to type in the pound symbol again, or the hash symbol again. If I want to create a multi-line comment, I can use 3 quotation marks, so like that, and then end it with another 3 quotation marks. And this is basically a multi-line comment. You can also do this with double quotes, it doesn't really matter. Just be consistent throughout your program. So just like before, in here, let's take this and put this in here, let's say 3 times. Let me just get it for the first one here, because these other ones are commented out. Cool. So that's comments. Now comments are really useful for commenting out code like we have done here. So by commenting out code, you can test different parts of your program, but they are also very useful for making notes in your code. So in the last video, we talked about the things I covered at the end of the video. So let's try and write those out as code, as comments in this file. So I'll just do a pound and let's say print used to show or used to display to the user, and end parameter used to tell Python how to end the print statement, and so on. So you can use comments to make notes in your program. Normally we don't really do this. Normally we use it to tell or to explain our code that might not be clear. But you as a beginner can use it to make notes in your code like this to get started. Awesome. So that's comments. Once again, to recap, comments are notes in your program. Python does not execute comments, and you can write comments in Python using the hash or the pound symbol for a single line comment, or 3 quotes for a multi-line comment. In this lesson, we are going to talk about input. So we use input when we want to get user input. So we want to allow the user to enter something on the keyboard. And the way we do that is just like print, we just type in input with open close parentheses. If I run this program now, you see we get hello world and a blinking cursor. So this blinking cursor indicates that Python is expecting us to type something. So I can type something in and press enter, and a program ends. Cool. So we have allowed our user to type something in, but we don't really know what they typed in, and we're not really doing anything with it. Let's try and show the user what they typed in. We do that by giving whatever they type in a name. So really we don't really know what the user types in, so we just give it some name, and whenever we use that name in our program, Python will replace it with whatever the user types in. I'm just going to call this A. So I'm going to type in A equals input, and I'm going to clear my console window. So you can do that with CLS if you're using command prompt, or the word clear if you're on Linux or Mac in the terminal. Okay, I'm going to run the program again. We got hello world. It's waiting for input. Type something in, press enter, and we don't get anything. That's because I forgot to put in print. So I'll do print A. Notice that A is not in quotation marks. Run the program again, type in something, enter, and we get back whatever we had typed in. Awesome. So once again, input, we use input to get something from the user. We give it a name because we don't know what the user types in. So whatever they type in, we give it a name, and then whenever we wanna refer to what the user typed in, we can just use that name. Now the reason we are printing A without quotation marks is because if we used quotation marks and run this, you see Python prints it out A. Whatever we put in quotation marks appears as is. So here essentially we're telling Python to print out the character A. When we don't use quotation marks, then Python is going to evaluate this, which means it's going to try and do a calculation on it. In this case, Python identifies that this is a name for something, and it figures out what it is that the name is referring to and shows us that. So in this case, it's for whatever the user types in, so it shows us what the user types in. Cool. Now let's create a program where we ask the user for their name, and then we say hello, their name. I'm going to give you guys a few moments to try it out. Give it a go, and then come back once you have had a shot at it. Cool. So I hope you guys gave it a go. The way we do that is, let's just say enter your name. They type in their name, and we can say hello space name. Now we discussed this in the first video. Essentially we need to separate this with a comma because the first part is in quotation marks, second part is not. So we need to separate the two with a comma. But when I run this, you see we get enter your name. I can type in, let's say, Melbit, and I get hello Melbit. Now right now we enter it, so the message displayed on one line, and then we enter our name on the second line. I like to put this on the same line. So once again, the video on print, I'm going to use end, and I'm going to say nothing, since I'm using double quotes. And now when I run this program, it says enter your name, and I can enter it on the same line. It says hello Melbit. Cool. So this works, but there is a better way to do this. We can actually type in the message directly inside of input. So if I just cut this part and paste it in input, you'll see that it works exactly the same. Enter your name and hello Melbit. Awesome. So this is how you can get input from the user. Let's do something a little more interesting. Let's try and create a program where we ask the user for two numbers, and with the two numbers we add them up. So once again, I'm going to give you guys a few moments to try it out. I'll give it a go and see how it goes. Welcome back. So I hope you gave that a go. Essentially what we do is we use two input statements. So I'm just going to say enter first number here. I'm going to call this num1, and then I'm going to create another number here, num2, input, enter second number. Then in our print I can do num1 plus num2. Okay, and I can say the sum of the numbers is, okay, let's just do that. Now when I run this, enter first number 5, enter second number 3, we get sum of the numbers is 53. Something went wrong. When we ask the user for some input using input, whatever is typed in is being interpreted as if it was entered in quotation marks. So essentially what's happened is when we typed in 5 for the first number, this is what Python sees. When we typed in 3 for the second number, this is what Python sees. And as I mentioned in the video on print, this is actually what we need, right? So this line is effectively 5 like that plus 3 like that, when what we actually need is this. Why does this happen? This is because of data types, which I'll cover in the next video. Welcome to the lesson on data types. So data types is basically how your computer or Python understands data. We have a bunch of data types in Python, but we'll just go over the more common ones to start off. So the first and one of the most common ones is a string, and a string is anything that appears in quotation marks. For Python, it can be either single or double quotes, but if it's in either of these, it's a string. Now we've used triple quotes before to for a multi-line comment. These are also strings, but we won't worry about those for now. As you continue in your programming journey, you'll see the use cases for these, but don't worry about them at the moment. Next we have integers, and these are positive and negative whole numbers. So 2, 3, -5, -8. An important thing to note is that these don't appear in quotation marks. So the value 2 in quotation marks would be a string. The value 2 without question marks is an integer. Next we have floats, and these are basically positive and negative numbers that have decimal places. So 5.3, -3.14. Once again, they don't appear in quotation marks. If these were in quotation marks, it would be a string. To create a float, they must be written without quotation marks. Finally, we have a bool, short for boolean, and this is a special case. It's basically the value true or false. This is case sensitive, so true must be typed in with a capital T and false with a capital F, and ensure that they don't appear in quotation marks. Now we can check the data type of a value using type. So just as we've used print and input before, there's something called type, and just like before, you use it with open and close parentheses. Inside the parentheses, you can type in the value for which you wish to check the type. So let's just check the type of true in quotation marks and true without quotation marks. Okay, now we need to surround this with a print so that it actually shows us the value that type returns or gets back. So we'll just do that, and I'm gonna run the program now. You see that we get string for the first one and bool for the second one, right? So quotation marks, string, without question marks, bool in this case. Now why is this important? Well, the data type of a value basically dictates what we can do with the data or how operations are performed on the data. So a simple example of that we saw in the previous lesson was with strings and integers. So in the previous lesson, when we asked the user for the first and second number, so something like that, and then we did print first plus second, we didn't really get the value we expected. So if I were to run this program and I did 5 and 3, 5 plus 3 actually returned 53 in place of 5 plus 3, so that's 8. And the reason for that is these data types. So input by default will give us a string, and in Python when you add two strings together, they are basically just concatenated or put together. So if I create another print statement down here, and let's say I try to do ASDF plus JKL semicolon, then let's see what we get. We get the two values combined. And once again, that's because in Python, string addition, so when you add two strings, they are basically just put together. Now since input by default supplies us a string, when we do first plus second number, it just puts the 5 and 3 together, which is why we get 53 in place of 8. Now what if we wanted to do addition with the two numbers? What if we actually wanted 8 instead of 53? Well, in that case, we need to convert the values from a string to an integer. So just like in the previous lesson, we convert the string to an integer using int. I'll just do that here. And now if we do the addition, so first number 5, second number 3, we get 8, right? So to convert from one data type to another, we basically have these functions that we can use. So to convert anything to an integer, we use int, open close parenthesis, and in here we'll have the value. To convert to a float, we have float, open close parentheses. To convert to a bool, we have this bool function. And to convert to a string, we use str, short for string. So if I wanted to convert this number 2 to a string, I could just do this. If I wanted to convert a string boolean, the string value true into a boolean, I could do this. And let's say we have something like that, something like this. If I were to print all of these, print, there we go. Let's see what we get. Yeah, we don't see much of a difference. So what I'll do is I'll just maybe add in type here so we can see the type. You see the first one is supplied it as an integer, but after conversion we have a string. Second one supplied it as a string, after conversion comes out as an int. Third one float and bool. Yep. So that's how you convert data from one type to another. Now what happens if your data is not valid? So let's say we have the string I, and we try to convert it to an integer. Now I is not really a number, so what would Python do in this case? We actually get an error. You see it says value error, so we get an error because I can't really be converted into an integer. So that's all for data types. To recap, data type is how your computer stores and understands data, and also figures out what sort of operations you can do on data. We have a few data types in Python, but the more common ones are strings, which are values in quotation marks, integers, which are positive and negative whole numbers, floats, which are numbers with decimal points, and bools, which is the value true and false. To check the data type of something, we use type. Just like we have print and input, we have type. And to convert from one data type to another, we basically surround the value in the data types function. And that's all for data types. Welcome to the lesson on variables. So variables are labels for data. We've actually already been using variables with input. So when I did input equals, a equals input, let's say enter a number, a here is a variable. In this case, we are creating a variable for a value we don't know, basically what the user types in. We can also create variables for our own data. So I can say b equals 5, c equals hello, and d equals some sort of a calculation. Let's say 5 times 3 plus 2. If I print all these out, a, b, c and d, you'll see that we get the values the variable stores. So a is whatever we typed in here, so that's 5. B has the value 5 as well, so you get a 5. C has hello, so you get hello. D is the result of this calculation, so 5 times 3 plus 2, 5 3 is 15 plus 2 17, and that's what we get here. We can also use variables in other variables, so I can replace this 5 with b and we'll get exactly the same result. So basically b is 5, so 5 times 3 is 15 plus 2 17, which is why we get 17. So essentially variables are labels for data, and wherever you use that label or variable, it's going to be replaced with whatever value you stored. We can check the data type of a variable with type, just like we learned in the last lesson. So if I run this, you'll see that we get string because a is coming from this input statement here, and I didn't do a conversion to an integer. And they function like normal data types, and their data type is basically the type of the value they store, and they'll behave as such. So if I did c, which is a string plus another string a, or let's say world in this case, then you'll see that for c we get hello world. C is essentially hello, and I'm adding the text world to it, so we got hello world. Variables are quite useful, and you'll be using them extensively in your programming journey. Now, in each of these examples, we've been looking at a case where the variable stores a single value. There are also variables that can store multiple values, and we'll be going over those next. Welcome to your next lesson on collection types. So far the variables we've created could only hold one value. So say for instance, if we have a variable a, what we did in the last video was set it equal to 2 or a string or something like that. basically just one value. A collection type is basically a data type that can store more than one value, and with that we'll be able to create variables that will be able to store more than one value. We have a few of them in Python, but once again we'll just stick to the simple ones for the moment. So the first one we have is a list, which is basically just a collection of data, a collection of items. Then we have a dictionary, which is a key value pair, and then a tuple or tuple. And this is similar to a list in that it's just a list of items, but the difference here is you can't change a tuple once it's created. Cool. So let's see a sample of each of these. We'll begin with the list. So we create lists with square brackets, just like that, and then in the square brackets we can have as many values as we like, separated by commas. We can also mix data types, so you can see I have 1 2 3 here, integers, and then I'll just add in a string hello, and I can say 3.14. Yep. So this is a list with 1 2 3 4 5 items, and I can print this out. Okay, so now if I open up CMD, go to my desktop and run the file, you see we get the list, right? And so I can set this to a variable, let's say my list, right? And I can print my list, and we'll basically get the same thing. So a list is a data type, just like integers, floats and all. It's just a data type that can store more than one value. Now if we wanna reference a list, we just use its variable name, but this will give us all values in the list like this. What if we wanna reference a specific value, say the first value? Then we need to use something called an index, and an index is just the position of the value in the list. Something to note about items in the list, I guess before that let's just see a sample of that. So let's say we want to reference the first item, so we can do my list square brackets, and here we're going to type in the position. So I wanted the first item, so that's at the first position, so I'll just type in 1, and if I run this, we get a 3, which is actually the second item. So what happened? Well, list indices start at 0. So even though the 1 is at the first position, for the computer it's actually going to start counting at 0. So it's going to say 1 is at position 0, the 3 is at position 1, the 4 is at position 2, and so on. That's something to keep in mind. It's something that tripped me up when I started my coding journey. It takes a while to get used to the fact that it starts counting at 0, but you'll get used to it pretty quickly. So once again, if we want to reference the first item, we'll say my list sub 0, or my list and 0 in the square brackets. If I do that, I got an error. Oh, it's because of this. Okay, should work now. There we go, we got 1. And in the same way, if we want to reference any of these items, we just use its index. So once again, indices start with 0, so this is 0 1 2 3. So if I do 3, we get hello, the fourth item. Now what if we want to add an item to the list after it's created? So when we create a list, we can add items here however we like. But what if I want to add an item after it's created? I don't want to change the entire list. I just want to add an item. By the way, if you want to change the entire list, I can just do this. 4 5 6, and if I do a print here, you can see that my list is now 4 5 6. But what if I just want to change one item? Well, you can simply do the list name or the variable name, and then in square brackets the index of the item you wish to change. So that's 0 1 2 3, so I'll just say 3 equals let's say 8. And if I do print my list, you see that the hello has changed to 8. And if we want to add an item to the list, we can do my list dot append, and then in parentheses I can say the item I wish to add. So let's just add 5, and if I print my list, okay, I'll just get rid of the index here so that we can see the before and after. And you see we have a 5 added at to the end of the list. So I can add as many elements as I like. Now what if I want to remove an item from the list, right? So adding an item just adds it to the end. What if I wish to remove an item? I can simply do my list dot remove and the item I wish to remove. So let's say I want to remove the item 4, print and you can see the item 4 is now gone. So that's lists. Next, let's have a look at the dictionary. So the dictionary is a data type that basically stores key value pairs. So we create a dictionary with curly braces like that, and for every value we have something called a key. We have a colon, and then we have the value, right? Now your key can be anything, so I can also put in like a 1 here. Now if I print this out, so I'll just comment these out so that they don't interfere with the dictionary output. You see we get key value, right? Let's just change this to name, and let's just say Melbit, age, let's say 1, is the first year of the YouTube channel, and for now we'll just leave it to that. If I print this out, you see we get name, Melbit, age, 1. What is the purpose of this key value pair? Basically what I can do now is get a value from the dictionary based on the key. So let's say if I want to get the name, I can just do same as before, square brackets, name, and if I print this out, I get whatever was stored in the name. Similarly, if I do age here, then I get 1, whatever value is stored for the age. And if I want to add another item to the list, to the dictionary, I can just do name of the variable in square brackets, my key. So let's say I want to add the key 5 color and set that equal to something. So let's say orange or black or whatever, doesn't really matter. And if I print out the variable, you can see that the new element was added to the dictionary. And if I just retrieve the favorite color, You can see we get black. Yep. So this is useful for storing data, key value pairs. And finally, we have the tuple. So we create a tuple using a comma. So what I'm going to do is just create a variable here, set it equal to, and I'll just say 2. Now if I just do 2 and I do a print, print the type of the variable, you see we get int. So it's not really a tuple at the moment. To make it a tuple, I need to put in a comma. So now if I run this, we get tuple. Okay, it's common convention to surround tuples in parentheses. This is not required from a language perspective, but it's common convention and helps us to differentiate it from like normal expressions that are separated by commas, right? So if I did something like this, 3 4 5, it should work. Okay, so I can just take this out probably. You see we get the type as tuple, but if you look at the values, yeah, we get that. And you'll see even Python surrounds it in parentheses. So it's not required, but it's common convention to use parentheses. 2 3 5, 2 3 4 5. Okay, and if you want to get an item from the tuple, so just like with the list, I can say my tuple and then in square brackets index of the item I wish to retrieve. So once again, indices start from 0. So first item is going to be index 0, second one index 1, index 2, index 3. So let's say I want to retrieve the first item, I just do in my tuple sub or in square brackets 0, and we got 2. What happens if you try to change a value? Let's say the first item equals 5. You see we get an error. Tuple object does not support item assignment. So a tuple can't really be changed once it's created. But let's try doing something like this. So let's try reassigning it to a new tuple. So let's just say 987. And any guesses on whether this works? You can see that this works. So we can reassign it to a new tuple. We can reassign our variable to a new tuple, but we can't really change the already existing tuple. That's the key difference between a list and a tuple. Welcome to the lesson on conditionals. So conditionals allow us to execute code based on a condition. If some specific condition is met, then a piece of code executes. If it's not met, it is not executed. In Python, the conditional we normally use is an if statement, right? So we have an if statement, and the way an if statement works is we have the word if, and then we have some sort of a condition, basically the condition that decides our if our code will work or not. So we'll have if condition, and then after that we have the code we wish to execute if the condition is true. So some code, right? Let's go over an example of this. Let's say in normal English terms, I say that I won't be going to town tomorrow if it rains. Okay, how would I write that in code? So let's say we have a variable that says if it rains tomorrow or not. So let's just say forecast equals raining, right? So let's just say weather. Okay, so we have a variable weather that just says raining. Now, so I said if it rains, I am not going to go to town tomorrow. So if, what I'm going to do here is check if weather is equal to raining. And if it is, then I'm not going to town tomorrow. Cool. So basically what I'm doing here is I just have a variable weather that stores the value raining, and in the if statement I am just saying if weather is equal to raining, then print I'm not going to town tomorrow. Let's see what happens. I'll just clear my console. Okay, and we get I'm not going to town tomorrow. Why? Because you can see weather is raining. Let's change this to not raining, and if I run the code now, you see we get nothing. And that's because, once again, for this code to run, weather needs to be the word raining. If it's anything else, this code will not run because this condition is false. Something to note, I'm using double equal signs here. So a single equal is used to assign a value to a variable. It's basically used to assign a value to a variable. So Python uses double equals to kind of differentiate from the single equals. We use the double equal when we're checking the value of something. Now, so weather is not raining. So since this is not true, this does not run. What if I want to say if weather what if I want to say if it's not raining, then I'm going to town? Well, another thing I can do is if weather not equal to raining, so the opposite of this, print I'm going to town. Okay, and you can see we get I'm going to town tomorrow, because this one's false since this is not raining, and this one's true since indeed the variable weather is not equal to raining. So we get this. Now this works, but there's a better way of doing this, and that's using the else statement. So that looks like this, and the else statement is essentially equivalent to otherwise. So if I were to read this out, it would be something like if weather is raining, if weather equals raining, I'm not going to town tomorrow, else, we won't have this part, else I'm going to town tomorrow. So with the else statement, we don't really have a condition. The else is basically if the if statement is not true, then run this code. And if I execute, you see it says I'm going to town tomorrow. So that's the if and the else. If weather is raining, I'm not going to town, otherwise or else I'm going to town. And if I change this to raining, then we get the first one, which is I'm not going to town tomorrow. Notice that we didn't get both of those statements, we only got one. So in an if statement, only one of the statements is going to execute. So only one of these code blocks is going to execute. It's not going to execute both of these. It's just going to execute one. If it runs this one, it's not going to come to this. If it does not run this one, then it's going to come to this. Now here we're just testing one situation, which is if the weather is raining. What if we wanted to test more than one? Well, then we use elif. So elif is short for else if, and the way we use it is we type in elif and our second condition. So I can say weather equals snowing, maybe, print I'm taking my jacket. So the way this works is it's going to check this first condition. If this is true, it's going to check this first condition. If it's true, then it's going to print I'm not going to town tomorrow, and that's it. It's going to come down here afterwards. Now if this is not true, it's going to check the second one. And if this is true, it's going to print this and come down. If it's not true, then it's going to go to the else and just print this out. So let's test it out. You can see currently weather is raining, so I'm not going to town tomorrow. If I change this to snowing, we get I'm taking my jacket. And if we change this to, let's just say sunny, I'm going to town tomorrow, which is this last one, because it's neither snowing nor raining. Now we can have as many elif statements as we like, so I can actually check a whole bunch of things in here if I wanted to, but we're only going to have one else statement for each if block, right? However, I can create as many if statements as I like, so I have one if statement here, but if I wanted to, I can create another one down here. That's fine. Cool. So that's really all for if statements. I'm going to give you a brief challenge, a very simple one. All you have to do is you ask the user for some number, and you're going to print out number is positive if it's more than 0, number is negative if it is less than 0, and number is 0 if it's 0. Okay, so pause the video here, give it a go, and come back once you're done. Okay, I hope you gave that a go. So the task was to ask the user for some number. So let's just say num equals input, input, enter a number, and let's convert this into a integer. You can also do float. Then let's check if the number is positive, negative, or 0. So if num greater than 0, so that's how we check for greater than, using the greater than symbol. We want to display number is positive. Elif num less than 0, print number is negative. Else number, print number is 0. Okay, let's test it out. It says enter number, let's enter 5. It says number is positive. Yep. Let's try again. Negative number, negative 7, number is negative, and let's try 0, and we get number is 0. Cool. Now if I wanted to, I could actually skip on the else statement, so I can just do num equals 0, print. Probably should not have deleted that, but that's fine. And if I run this now, 5 was positive, negative 5, negative, and 0. Yep. And you see it works fine. If you want, you can omit the else statement. So it's not mandatory that you include it with all of your if statements. Yep. Awesome. So to recap, we use if statements to execute code conditionally. That means based on a condition, and the format is if some condition, then the code you wish to write. Note, the code we wish to execute, if the condition is true, is going to be indented inwards. That's how Python basically tells what's the code you want to execute if the if statement is true, right? So yeah, and you wanna have all these spaces equal. So if you're using 4 spaces or a 1 tab, then you wanna make sure that you are using that throughout, otherwise you'll run into errors. In this lesson, we are going to be looking at loops, specifically while loops. So loops allow us to execute a piece of code over and over again. There are 2 main types of loops in Python. Those are while loops and for loops. In this lesson, we're going to be looking at while loops. So the way we write a while loop is basically with the word while and then some condition. So for this demo, let's create a variable num that is equal to 10, right? And we'll say while our number is greater than or equal to 0, what do we wish to do? I wish to print the number. And finally, I'll say number equals num or number minus 1. So what this will do is it will basically just count from 10 down to 0. So let's see that in action. And if I run the code, you can see we get 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. What's happening here is we create a variable num and we set it to 10. Then we have a while loop. We're checking, so while loop, we're checking if number is greater than equal to 0. If that is the case, then it runs the code that's underneath the while. So in this case, we print the number and we subtract 1 from the number. So now our number is actually 9. And then it checks, is 9 greater than equal to 0? Yes, so it prints it out. And subtracts 1, it becomes 8. Is 8 greater than equal to 0? Yes, prints it out. Becomes 7. Is 7 greater than equal to 0? Yes, prints it out. Becomes 6, and so on until it gets to 1. So is 1 greater than equal to 0? Yes, prints it. 0 greater than equal to 0? Yes, it's equal to 0, so it prints out 0. Subtracts 1, becomes negative 1. Is negative 1 greater than equal to 0? No. So this condition is false, so the loop stops and your code finally comes down here. If I actually print num, you see num is actually negative 1 at the end. Cool. So currently I'm subtracting 1, which is why num eventually becomes less than 0, right? And this condition terminates. But what if I actually didn't do this? I run the code now. You see we keep getting 10s and the program just continues. It still hasn't stopped. It just keeps printing 10. To exit out of this, I need to press Ctrl C, which basically just stops the program. What you just saw is called an infinite loop, and it's a situation where your program gets stuck in a loop. The condition never becomes false, so it just gets stuck in the loop, right? So what happened was num is set to 10. Is 10 greater than equal to 0? Yes, so it prints 10. And this line's commented, so goes back. Is 10 greater than equal to 0? Yes, prints 10. Is 10 greater than equal to 0? Yes, prints 10. So it just keeps on going and going and going. It never comes to the next bit of code that you might have at the end of your program. So just to show that, if I had, let's say, this at the end, this part would never be executed because the program is stuck in the loop. So if I run this again, you can see we just keep getting 10s. So this is something to note. It's a gotcha. Always ensure that your while loops terminate. Otherwise your program is going to get stuck and it's likely that your OS is going to terminate the program. Okay, so in this case we counted from 10 to 0. A quick challenge: try printing all of the even numbers between 2 and 20. Right, so on your console screen you should see 2, 4, 6, 8, 10, 12, 14, 16 up to 20. Give that a go and we'll check it out in a sec. Okay, I hope you gave that a go. So what we want to do is we want to start at 2. So I'll set num to 2 and then I'm going to say while num is less than equal to 20. Okay, because we're starting at 2 and we'll be going up to 20, so I'm going to say less than equal to 20. I'm going to print num, and then down here I'm going to be adding 2 to num instead of 1. Once again, the reason I do this is because we want 2, 4, 6, 8, 10. If I added 1, we'd get 2, 3, 4, 5, 6, 7, 8, 9, which is not what I want. Wanted to increase by 2, so I'm going to add 2 to it. We can add 2 this way, or in Python, a shortcut for adding a number to a variable is this plus equals. So I can just do num plus equals 2, and this just means num equals num plus 2. Okay, I'll get rid of this, and if I run the code now, okay, you see we got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Cool. And again, this condition can be anything you like, so you can even sorry, not the condition, this statement can be anything you like, so you can even do something like times equals 2, so it's going to multiply it by 2 every time. So you get 2, 4, 8, 16, and so on. We'll be continuing with loops for this lesson. I will talk about for loops specifically. Like a while loop, a for loop executes some code over and over again. The difference with a for loop in Python is a for loop works over some sort of a collection, so a bunch of values, right? Let's start by translating this into a for loop. So what I have here is a variable num that is just equal to 0, and I'm checking if num is less than 10. If so, I'm printing num and adding 1. Convert this to a for loop. I'm going to say for num in range 10, print num. And if I execute this code, I'm just going to print I'm just going to put a separator here so that we can see the while and the for separately. If I run this code, you see we get 0 to 9 for the while loop and 0 to 9 for the for loop. Same thing, just written differently. So what's happening here is num is a variable that we're creating. In a for loop, the variable is created right in the loop. We don't have to create it beforehand. Now for loops work on some sort of a collection, some sort of a group of values. So it can be a list, it can be a tuple, it can be a dictionary as well, but that works a little slightly differently, not too different, but needs to be some sort of a list. Range helps us create a quick list, which is why I'm using that here. I could have just done my list equals 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and I could have replaced range with my list. This would have worked fine. Run this, you can see we get 0 through 9. And if I actually changed my list to be hello and world, we get hello and world. So really it's going over some sort of a list or some sort of a collection. Why did I use range though? Well, range is a function in Python. So just like we have input and print, range gives us a list of numbers, and in its most basic form, it's going to create a list of numbers from 0 up to, but excluding the number we specify. So since we specify 10 here, it creates numbers up to 9, from 0 to 9. If I wanted 10, I would have to say 11. And you can see we get 10 now. If I wanted 20, I would have to say 21. So basically one more than the number of elements you want. But what if I wanted my numbers to start at 5? Well then I would, so before 21 I would just put in 5 separated by comma. So now my numbers would start at 5 and go up to 20. So you can see 5 through 20. What if I wanted to increase by 2? So just like in the previous lesson where we incremented by 2 for the even numbers, what if I wanted to increment by 2 in this case to get all the odd numbers? Well, after the 21, I can just put 2 here, and what this will do is it'll start at 5 and keep adding 2 until the value is less than 21. So there you go, 5 through 19. So that's for loops. Once again, they help you execute some code over and over again. The difference between a for loop and a while loop is basically that a while loop executes while some condition is true, while a for loop executes on some sort of a collection. It can be a list, it can be a tuple, it can be a dictionary, but some sort of a collection. So I have my list here. I'll just change this to a tuple, and if instead of this range, I'll just say my list to use this. And if I run this now, you see that the for loop executes over the values in the tuple. Like I showed you for the list, if I do 1 2 3, it goes over the values in the list. Now I said the dictionaries were a little different, so let's try that out. I'll just say 1 to the value 1, 2 to the value 2, and 3 to the value 3. Okay, so for num in my list, print num. Let's see what this gives us. I'm going to get rid of the while bit just so our window is clearer. And you see we got 1, 2, and 3, which is actually the keys in our dictionary and not the value. So if we wanted the values, one thing we could do is say my list sub num. So now we'd be getting the values since num is storing the keys. Another thing we can do is actually say for key value in our dictionary, I want to print the key and the value. So if we say for key value in our dictionary and we need to say dot items and we print the key value, we get we get our key and value pair, right? So just like we had append for lists and remove for list, we have this dot items for our dictionaries, and this just gives us a key value pair that we can use. We'll now talk about functions in Python. Functions are a way to group and reuse code. The demos we have been writing so far have been short. However, as you build scripts and programs, it becomes hard to follow and keep track of things. Sometimes we find ourselves repeating one piece of code over and over again as well. So we use functions to group code into a block so that our program is easier to read and follow, and so that we can reuse code that we have written without rewriting it. To create a function in Python, we use the def keyword. Def is short for define, and it just tells Python that we are defining, that is creating a function. We give our function a name, just like we've been doing with variables. So I'll call this print hello, and then we follow this with open close parentheses and a colon. If I press enter, you see that VS Code indents the next line by a bit. So what I'll do is just type in print hello world, and this is basically the code that is executed when I run my function. So I'll go to command prompt and I'll just run the script, and you see that nothing really happens. That's because we have created our function, but we haven't told Python to run it. And so we need to tell Python to run our function. The way we do that is we write the function name to print hello, followed by open close parentheses. And this just tells Python that we want to run our function. The technical term for this is calling a function, which just means running or executing a function. Okay, so I have print hello here. I'll run the script again, and you see we get hello world. We can run our function as many times as we like. So I'll just copy this and paste it 3 times or 2 times. So we get 3. So that we are calling the function 3 times. And if I run the code, you see we get hello world 3 times. So we can call our function as many times as we like. Now something to note is the indentation level. Print hello world is indented by 4 spaces, whereas when I'm calling the function, you see that it's right up against the left margin. This indentation is really just to tell Python that this block of code belongs to the print hello function. So any code that does not belong to the function will not have that indentation level. One note, you must be consistent with the indentation. So if you use 4 spaces, all the code that belongs to the function needs to be 4 spaces. If you did 4 spaces and then 2 for the next, this would cause some errors. So ensure to be consistent. Okay, cool. Next, let's do something a little different. Let's supply the data that we want the function to print. Okay, so instead of printing hello world, we'll tell it what to print when we call the function. How do we do that? We can supply data to our function by giving the data a name, and that name appears in the parentheses. So I'll just say text, and text will be what we print in the function, right? So inside my print, I'll just replace this with text. Essentially what's happening here is text is a variable that will store some data we give the function, and whenever we use text in the function, important, whenever we use the text in the function, it's going to refer to the data we supplied, right? So if I do this and I run my program, we get an error. It says print hello, missing one required positional argument, text. What this means is print hello is expecting some data that we have named text, but when we are calling the function, we aren't really supplying that data. So how do we supply the data? We just type it out in these parentheses. So I'll say hello for the first one, world for the second one, and let's say it's a good day for the third one, right? And if I run this, you see we get hello world, it's a good day. What's going on is when Python runs the when Python calls the function the first time for line 9, it's setting text to hello. So in the function, when we print text, we get hello. When calls it the second time, it sets text to world, so we print and we get world. And in the third time, it's setting text to it's a good day, and when we print, we get it's a good day. Cool. So you're not limited to one variable for the function. You can have as many as you like. So I'll just put in num here, and we can supply a number as well, 5, let's say. And if I run, yeah, I'm just getting hello world, it's a good day, because I forgot to use num. So let's just print num on the second line, and we get hello 2, world 3, and it's a good day 5. Let's just create a function that takes in 2 numbers. So I'll call those first and second, and prints out the sum of the 2 numbers. So sum first plus second, right? Adds them up. And I'll just rename my function to add. Cool. So down here, I'll call add with 5 and 3, and I'll do another one for 5 and 5, and let's do a third one for 3 and 2. And when I run my program, I get 5 and 3 is 8, and 5 and 5 10, and 3 and 2 for 5. So far I've been writing only one line in our functions, but we can have as many lines as we like, and we can have any bit of Python code that we desire. So I'll just say sum equals first plus second and print out the sum, and we get the exact same result. There we go. Now here we are printing the sum directly, but what if we wanted to get the sum and then do something with it? So essentially what we want our function to do is do the calculation and then give the number back to our program so that we can do something else with it. How can we do that? How can we, instead of displaying it here, do the calculation and give it back to our program down here so that we can do something with it later on? Well, we can do that with the return keyword. So we just type in return and the value we want to give back to our program. So I'll just say return sum. And now if I run my program, you see nothing really happens. That's because the function is doing the calculation, supplying the value back, but we don't really do anything with it. So how can we see what it's giving back? I can do a print here. And if I run my code now, you see we get the result of the calculation, the result of our function. I can also assign the result to a variable. So I'll just say A equals the first one, B equals the second one, and C equals the third one. And I'll just print out A, B, and C. If I run my code, you see we get 8, 10, and 5. Now that these are variables, you can use them in your program like normal. So now I have a challenge for you guys. I'd like you to write a program that asks a user for a length and a width. Your job is to create two functions, one called area and another called perimeter, that basically calculates the area and perimeter of a rectangle with the supplied length and width, and then display the result to the user. So give that a go and come back once you're finished. All the best. Okay, welcome back. Hope you gave that a go. Now what we want to do first is ask the user for a length. So I'll just say length equals input, enter the length. We'll just keep it simple for this demo. And this is a string, so we need to convert it into an integer or a float. So I'll just do float, and I'll copy this line and make it width, enter the width. Then I'm going to create my two functions. So let's do area first, def area, and I'll say area equals length times width, return area, right? And in my function parameters, I'm going to add length and width, right? So we supply a length and width to this function. It calculates the area based on the length and width and returns the area. I'm gonna do def perimeter, same thing, length and width, and we can say perimeter equals length plus width times 2. Now be careful to add parentheses with the length plus width because of badmess/pemdas rules. I'm gonna do return perimeter. Awesome. So we have our two functions. Now we just wanna calculate the area. So I'll say area equals, we'll call the function area and we'll supply our length and the width, and we'll do another perimeter equals perimeter length and width, and let's print it down here. Area and perimeter. Cool. Let's run this program. It enter the length 5, enter the width 3, and you can see area is 5 3 is 15, perimeter is 16. Awesome. So that's the code for the challenge. A few notes and improvements. Firstly, I like to keep my functions in one place and my code that does the actual work. So this and this in one place. So what I'll normally do is have the functions at the top of the file, and I'll just move this code, the working code, to the bottom of the file together so that it's easier to find and work with. In this lesson, we're going to be looking at importing code into our programs. So this code can be from modules from other Python files that we create or that someone else creates, or it can be from libraries as well. So Python provides a few modules for us to use. These are basically some code that someone else wrote that we can bring into our program and use. They basically make something easier for us. One such module is the math module. This comes with Python and we can import it using the keyword import. So at the top of our file, we just type in import and then the name of the file, or in this case module. So I'll just type in math to import the math module. And then we can basically use everything that's available in the math module. So one thing that it provides is the square root function. To use that, I can just do math.sqrt and in parentheses the value wish to square root. So I'll just do 25 as an example. And what I'll do is create a variable and let's print this variable out. Okay. If I run my program, you see we get 5.0, which is the square root of 25. Something else the math module provides is a value for pi. So if I just print math.pi and run this program, you see we get 3.14159 blah blah blah. So that's a pretty accurate value for pi that we can use in our calculations. In addition to this, it has a whole bunch of other functions. If you actually go onto Google and type in Python math module, W3 schools, so that's this link here, W3 schools, and it goes to there, Python math module, you can see all the functions and a few constants that the math module provides. So you have ceiling function, you have asine, sine is somewhere here as well, cosine, tangent functions, is infinite, so that just checks whether a number is infinite or not, and so on. So you can reference this to get more info on the math module, but the main purpose of this lesson is really how to import modules and other files. So we'll stick to that for now. Now you can see that whenever I want to use something from a math module, I have to type in math. If I wanted to, I can actually say import math as m, and now instead of typing in math.square root, I can say m.square root and m.pi. If I run my code, you see we get the same result. I can actually take this a step further and say from math import sqrt, and now I don't need the math or the m dot. I can just call the square root function directly. So if I just print a, you see we get 5, and similarly I can import pi. So I can do this again, import pi from math import pi, or you just put a comma here and say pi. So if I print pi, we get the value for pi. Cool. And you can add an as statement here as well. So I would have to say as, let's say s. So now if I say s, print out a, there you go, 5. So you can actually alias this as well. So that's really it for importing modules in your programs. One note, we normally have our imports at the top of our file. You can actually place it anywhere you like, as long as it's before you use the function. So if I did this, I would actually get an error. I have to say sqrt. There you go. Because it comes here, it sees square root, but it does not know what it is. So we need to import it before we use it. But it's best practice to put these imports at the top of your file, just for the sake of clarity. In the last lesson, we checked out how we could import code from other files and modules into our Python program. In this lesson, we'll extend on that a bit and check out how we can install additional modules or packages into our Python installation. So I'll just go to Google and I'll search for matplotlib. Matplotlib. This is a library that allows us to make graphs and charts in Python. It's actually quite heavily used in when doing data science or data analysis work. But the focus of this tutorial is really how to install these packages. So if I go to the website, somewhere on the website it's going to tell you how to install the library. In this case, I'm going to click on getting started, and it tells you installation quick start, install using pip or conda. We won't worry about conda, but install using pip says pip install matplotlib. So to install this library, what we have to do is copy this pip install matplotlib, copy, and we want to paste it in our console window. So terminal on, if you're on Linux, or command prompt on Windows. You can also use the Windows terminal. Whatever you're using, you just want to do pip install matplotlib. So that's exactly what they provided here. So I'll just press enter. And what this will do is it'll get the matplotlib library and install it in your Python, in your installation of Python. And from there, just like we did for math, we'll be able to import and execute functions and features from the matplotlib library. Once this is done, okay, it's done. I'll just copy this code for simplicity. You see, we are importing matplotlib. We are also importing something called NumPy. That's another library quite heavily used in the data science and data analytics space. We have some code here, and then this is just using some functions in the matplotlib library. So this np is using something in the NumPy library, and this bit is using something from the matplotlib library. If I run this file, I can find the instruction. Okay, there we go. And you see we get a chart. Now, once again, this code is not what's important here. Basically, the main idea of this lesson is to show you how you can install libraries and packages that you find on the web. So sometimes you'll come across websites that will tell you to install the package or library using pip. So in that case, you just copy this, paste it in command prompt, and it should work. If we wish to see all the packages we've installed, we can just do pip list in our command prompt or terminal, and if I hit enter, you'll get a list of all of the packages that you've installed using pip. And if you want to remove a package, you can do that with pip uninstall and the package name. So let's say if I wanted to remove matplotlib, I can just do matplotlib. So pip uninstall matplotlib, and it's going to ask me to confirm. So I'll just do y, and there you go, it uninstalls matplotlib. So if I did pip list again, okay, so there's this matplotlib inline, but that's something else. You can see matplotlib is not here. If I were to install it again, let's do pip list. Yeah, you can see matplotlib here. So this inline is something else. Matplotlib was the one that was uninstalled. One more useful function with pip is the ability to create a list, a file with all of the packages you've installed. So what I can do is pip freeze space, and I'll put a greater than symbol, space, and the name of the file you wish to write this to. So I'll just say requirements.txt. That's normally the file you create for this. So once again, pip freeze greater than sign the name of the file, which is usually requirements.txt. And if I hit enter, give it a second, you can see we get a requirements.txt file whichever folder was open in our command prompt or terminal. So if I open this up in VS Code, you can see the list of all of the packages that we'd seen earlier. So we can find matplotlib here as well. There you go. And this equals, you have the version number. So let's say you want to install all of these packages on an installation of Python that does not have them already. You can see it's quite a bit. So going through these one by one will take a bit of time. So something you can do is pip install -r and then the file you wish to use. So requirements.txt. And what this will do is it'll go through the file and install all of the packages that are listed along with the versions. This is quite useful when you're working on one machine for development and then you have to release it on another or maybe on a server. Then you can create the program on your machine, create this requirements.txt file, and then install all of the packages on the production machine using this requirements.txt file. In another lesson, we'll discuss how to create an environment, which is basically like a self-contained installation of Python where you can install all the packages you like and it's not going to affect your main installation. In this lesson, we're going to be looking at file IO, that is reading and writing data to and from files. There are two methods for this. In this video, we're going to be checking out the first method, and then in the next video, I'll show you a slightly better way of doing that. Okay, so in my Python script, I'm just going to type in my file equals open. Let's say save.txt r, and there we go. So what this does is, open is a function just like input and print that'll open some file. So this is the file I'm telling it to open, save.txt. R is the mode. In this case, I'm opening it in read mode, right? There are three modes available. There is R for read, write, W for write, which will overwrite any data that's already in the file, and there's A for append, which will open the file for writing, but it's not going to override what's already in the file. It's going to add to it. So we have a file open and it's stored in this myFile variable. To read data from the file, I have a few functions available. I'll just say data equals myFile dot read, And what this will do is it will read all the data in the file. Let's print the data out. And we'll say my file dot close. Whenever we open a file like this, we want to ensure to close the file after we are done. If I run this program now, you see it says it's pointing to open save text, and it says no such file or directory, save.txt. Basically there is no file called save.txt, so I need to create that. Since we are on the desktop and we didn't supply a path, the desktop is where it's going to be looking for the file. So I'm going to create a new file and I'm going to save it on the desktop as save.txt. In this file, I'm just going to write a sentence. This is a sentence. I'm going to copy this, let's say 5 times, save, and let's run this program again. We get this is a sentence 5 times. So once again, reads the entire file in one go. The next function we have is read line. To show this, I'm just going to add a number at the end of each of these lines, just so we can see what line we are on. And now if I run my program, you see that we get only one line. This is a sentence 1. It basically just read the first line. If I run it again, we get the same thing. If I copy this and paste it down here, so essentially I am reading a line, printing it out. I'm reading a line again, printing it out. Let's do this a few times. So 3 times. Run my code again. You see we got this is a sentence 1, this is a sentence 2, and this is a sentence 3. Read line reads the file one line at a time. What if we wanna go through the entire file line by line? You can actually do this in a for loop. So you can say for data in my file dot read line print data. So to actually go through the file line by line, we actually need to do read lines. And if I run this, we are going through each line at a time. So yep, that kind of simplifies the process of reading all the data in the file line by line. Now you'll see we have this extra empty line here that we don't really have in our program. So why is that happening? That's basically happening because there is a character at the end of the file that puts in this empty line for us. We can get rid of it with data.strip, and you can see that gets rid of the empty line. Cool. So that's how we can read data in a file. What if we wanted to write some data into the file? Well, I'm going to now open this file in write mode, and something to notice, we have some data in the file. I'm going to write my file dot write Python code, and let's run this. Before we run this, note that this will overwrite what's existing in the file. So if I run this, okay, no errors. If I go back to my file, you can see everything in the file was replaced with Python code. If I do another myfile.write, this is another line. Run. You see that we get this is another line attached to the first line that we had entered into the file, Python code. So how can we add a line? There are two things we can do. One is we can add that character that I mentioned earlier. So that character is actually a /n, and what this does is enter a new line into the file. It's as if I pressed enter here. If I run my program now, go back, you can see that this was moved to another line. Let's add like 2 or 3. So I'll just do 3. And you can see some empty lines. If I copy this, this is a 3rd line. You see that now these two are scrunched together. So you always got to remember to add in an empty line. Another way to do this is using the writelines function. So writelines takes a list of items that you wish to write to the file. So what I'll do here is I'll just say data equals a list of all this text. And I've removed the /n's for now. What I want to do next is my file.writelines, and I'll just say data. Run my program. You can see the 3 lines were written to the file, but once again they are scrunched together. So what I'll do is just do a /n once again. And you get each line on its own line. So finally, let's look at append. So as I mentioned earlier, append will add lines to your file. So what we want to do is open the file in append mode. So we'll put A here, and we are once again going to write data to the file. And I'm going to say write, this is an appended line. So we'll do a /n. And once again, we have 3 lines in the file, Python code. This is another line, this is the 3rd line. Maybe for this one, we can do something like AAA, just so it's a little clearer. And if I run my code, you can see AAA was added to the line instead of overriding everything that was already there. If I change this to B's, and you can see B was added to the line as well. In the last lesson, we saw a method of reading and writing data to and from files. We'll do the same thing in this lesson, but we'll use a slightly different and better approach to actually working with the file. What I'm going to do is just get rid of what we already have here, and I'm going to say with open our file name, so save.txt. I'm going to open it in read mode as our variable. So I'll just say in file. This can be my file as in the previous lesson, but I'm just used to using in file. And down here, whatever we want to do with the file. So I'll just say data equals in file.read, like we saw in the last lesson, and print data. So the cool thing about this method is we don't actually need to close the file after we are done with it. The with statement will automatically open and close the file for us once it's done working with it. So I'll just come in here and run my code, and you can see we get all the data that was in the file. If I go to the file, you can compare it there if you like. But yep. So this is a quicker and easier way of working with the file, and it also ensures that your file is automatically closed after you're done working with it. So in the same way, what if I wanted to write data to my file? So I can open it up in write mode, call this out file, say out file.write. This is written to the file. Let's get rid of this. Okay, now if I run my program, okay, and you see we get this is written to the file, and I can go append mode, run the program. You can see that it's added the second line as well. I'll just do a /n here, save, run, and you can see a third one was added, but it was not added to the new line. But if I run it a fourth time, you can see the next one appears on new lines. Okay. Awesome. So I'll just go back to read, call this in file. So the first way of reading data we saw was in file.read, which just reads all the data in the file. There we go. Let's try reading the data one line at a time. I'll just rewrite this to say line 5, 4, 3, 2. So line 1, 2, 3, 4, 5. There we go. Now, what if we're reading the file one line at a time? We can just do for data in file.read lines, print data, and just as before, we get each line in the file one at a time. I can do a dot strip to get rid of that extra empty line that we have. There we go. And I can work with this file one line at a time, however I like. Awesome. So that's all for this video. And reading and writing data to and from files in Python. In this video, we'll be looking at virtual environments in Python. So if I went over to my command prompt and I did pip list, this will show me all of the packages I have installed with my Python. So currently there's only one, pip. Now as you build projects, you'll be installing all sorts of packages. The issue with that is twofold. One, sometimes one package or library depends on a specific version of another. So say we have matplotlib, and basically matplotlib say depends on another package, pandas. Just for the sake of example, there may or may not be a relationship between these two, but we'll just use this as an example. Say matplotlib depends on pandas version 1.3 as an example. So that means if you want to use these two together, I need this specific version of matplotlib. So this is fine for this project, but say I have another project that needs the latest version of pandas, and I don't really need matplotlib there. Well, in that case we have an issue, because I need both of these but for one project, and I have another project for which I need a newer version of this. So that's one issue. And the other issue is when you work on lots of projects, your installation of Python can get polluted in a way with all sorts of packages. So we can get around this issue with virtual environments, and the idea is to create like a separate, in a way, a separate installation of Python where you can install all your packages. And when you deactivate that environment, basically all of those packages go away. So let's see how that works. To create an environment, we do python -m venv. So venv is actually the program inside of Python that creates our virtual environment, and then we give it a name. So we can give it any name we like. Ones that I use commonly are env or venv, and I even do .env or .venv sometimes. It's really up to you. You can call it ISDF if you liked. and that will create a virtual environment for us. But before I hit enter, what I'll do is I'll actually just create a folder on my desktop, and this would normally be my project folder, which will have all of my Python scripts and other files in it. So in command prompt, I'll just cd into this folder, so cd project, and in this folder I'll just do python-m vn, and let's just call it env for now. I'll hit enter, give it a sec to create the virtual environment, and once done, you'll see that we now have a .env folder in our Python, in our project folder. We don't really have to worry about what's in this folder, but currently we are not really in this environment. So I'll just activate the environment using env, so that's the folder /scripts /activate. And what this will do is it'll basically activate the environment for me. So I hit enter, and now you'll see that at the front of my current line command prompt, you'll see this env in parentheses. This basically means that my virtual environment is active. Now I'll just do pip list, and you can see we have the same thing as before. Let's install a package into this virtual environment. So I'll just do pip install matplotlib. This is the same package from the pip lesson. Don't really worry about what this does. It's more about virtual environments than the packages or the package matplotlib. Okay, give it a sec, and it's done installing matplotlib for me. I'll just do cls, and I'll do pip list again. Notice that my virtual environment is active. So if I hit enter, we can see a list of all the packages installed. You'll see that we not only have matplotlib, but we have a bunch of others as well. This is because matplotlib depends on all of these to work. Cool, so matplotlib is installed, but if I just open up another command prompt, and you'll see that we don't have the virtual environment active here, and let's say I did a pip list, you'll see that we don't really have all these packages installed in here. So that's really one of the key advantages of virtual environments. Your projects packages are self-contained in an environment, so it does not really mess up your main installation of Python, as I'd mentioned earlier. Now we can do whatever we like with this environment active, install the packages, create our program as normal. One thing to keep in mind is when you are running your Python scripts, so hello.py in this case, you need to have this environment active for this file to be able to use the package that you installed. So if, let's say, hello.py header line import matplotlib, I'll just save this. Okay, you can see I have my environment active here. If I did python hello.py, it works fine. But if this environment were not active, this would actually run into an error. So let's do that next. To get out of this environment, I'll just type in deactivate, and you'll see that the env in parentheses is gone now. So basically the environment has been deactivated, and I'll just run the file with Python again. So python hello.py, enter, and you see it says no module named matplotlib. If I do pip list, once again you don't see matplotlib. However, if I activate this environment again, there we go. So we have it active here, and I run the file again. So python hello.py, it works again. So always ensure to have the environment active when you're running your Python files for your project. Now, what if you wanted to move this project over to another computer? Well, if you just copied this folder, this project folder, and took it to another computer, you'll find that you aren't really able to activate your environment properly. The proper way to copy this project over to another computer would be to firstly create a requirements.txt file that just has a list of all your Python packages. So with my environment activated, I'll just do pip freeze requirements.txt. Okay, pip freeze greater than sign requirements.txt. We saw this in the lesson on pip, but I'll just do this, hit enter, and we get a requirements.txt file that just has a list of all the packages. Now what you want to do is copy all of the files and folders except your env folder, so your virtual environment folder. So copy all these over onto your new computer, and then on the new computer, so just to demo this, I'll just create another folder on my desktop. Let's call this project 2, and in this folder I'll copy everything except my virtual environment folder, and I'll just move over to that folder in command prompt. Okay, now you'll have to create the environment and install the packages again. So what I can do now is just create the environment again, python-m vn, and once again you can call it whatever you like. So this time I'll just call it vn. I'll activate the environment. So you can see I'm still in the env environment, so I'll just quickly deactivate that. And I'll activate my env environment. And then in here, I'll install all the packages from requirements.txt. So the way we do that is pip install -r requirements.txt, and that'll go ahead and install the packages from the requirements.txt folder. Okay, it's done now. And if I do a pip list, we get our list of Python packages. If I do python hello.py in my project 2 folder, you can see we don't get any errors. And if I deactivate my environment, okay, cls, and I did pip list, you can see my original installation of Python is pretty clean. So that's how you'd be moving your project over to new computers. In this lesson, we'll be looking at object-oriented programming with classes and objects. We won't go into the theory and details of OOP, but instead stick to the very high-level basics to get you started. OOP is an extensive topic in itself, and I don't want to confuse you with all the details before you've mastered everything we have seen thus far. OOP helps organize and design better code. The basic premise we'll be working with are objects. An object is composed of properties and behaviors. So we have an object, properties, behaviors. Properties are basically information or data about the object, while behaviors are things that the object can do. In code, properties are basically variables, while behaviors are functions. Let's say we are creating a game. Our game is going to have a player which we can represent as an object. So if we were to create a player object, it might look something like this. Our player object will have some properties which will basically be their health, their name if the game allows you to give your player a name, and maybe some ammo. Of course it can have lots more, but for this example we'll just stick to these 3. So this is the data for the player, right? The player health might be 100, player might have some name, and ammo, they'll probably have some ammo for if they have a gun or a bow and arrow or something. And then the behaviors may be walk, jump, run, shoot, etc. So those become the things that the player can do. Similarly, if we were to take a racing game, our car object might have a few properties like top speed, current speed, acceleration, and a few behaviors like accelerate, which just means going forward, reverse, and turning left or right. So these would be our objects with their relevant behaviors and properties. But how does this look in code? To create an object in Python, we first need to create a class. Our class just tells Python what our objects look and behave like. It's essentially a blueprint to the Python language for our object. Just like a blueprint for a house tells the builder or contractor what the house will look like. Using the class, Python will create our objects. Let's see this in code. We'll create a class for our player that we have here. Okay. So to create a class, we first type in class and then our class name. In this case, I'll just call it player. And you'll see Python indents the code for us. So whatever is indented by, in this case, 4 spaces, will belong to this class. So now we'll have our properties. So we have one for health, and we have another for name, and finally ammo. Now I mentioned earlier that these were variables, so we need to give these some value. Let's say health is 100, name is Frank, just a random name, and ammo is 50. And let's give it some behaviors. So I'll say def, walk, and for simplicity I'll just print walking. For our walk function, run, print running, def jump, print jumping. Now something to note, just like the variables in our class are called properties, the functions in our class are called methods. They are just like normal functions in Python, but it's just a technicality. So when functions don't appear in a class, they are called functions. When they do appear in a class, they are referred to as methods. And these variables become properties of the class or object. So we have our class here. Now I'll create an object from this class. So I'll just say player1 equals player. So that's the name of our class, and open close parentheses. This creates an object of the type player based on the rules we specified here. So let's say I wanted to see the player's health, name, and ammo. So I'll just do print player1. So that's the name I gave to my object. Dot health, player1 dot name, and player1 dot ammo. Cool. So if I save and run this file now, you see we get 100, Frank, and 50 for our health, name, and ammo. Now let's try running one of these methods. So I'll just say player1 dot walk, and this will basically execute or run the walk method in the player1 object. So if I run my script now, we actually get an error. It says player.walk takes 0 positional arguments, but 1 was given. Essentially what this means is this walk method is receiving an argument, but we don't really have any parameters here. Now why is this happening? Well, in the case of classes, all of our methods actually receive an argument by default, and this argument is actually a reference to the object itself. I don't want to get too complicated, but the gist of it is you need to have at least one parameter here, right? You can use whatever name you like for the parameter. I can call it ASDF if I like, but the convention is to use the word self. There we go. And self is basically a reference to the object that is created. So in this case, player 1, whatever object is created for player 1, self is going to refer to that. So now if I run my script again, we get walking, and I can also do player 1 dot run, player 1 dot jump. You can see we get walking, running, and jumping. Cool. What if I wanted to access these variables inside of my class? Well, I can just say self dot health, and this will basically print the health property. What I'm going to do is create another method here. Let's say def show data, and once again we need to provide at least one parameter by default for the object, and I'll say print self dot health, print self dot name, print self dot mo. And if I call player 1 dot show data, we get 100, frank, and 50 from here. So whenever you are referencing the properties of a class, you need to use the keyword self. If you remove this, run the file, you see we get an error. Now, what if I wanted to provide a value to this method? How can I do that? Let's say we have another method here, def change name, that basically just changes the name parameter to something that we provide. Well, what we do is we add another parameter to our method. So I'll just say n for name, and we can use that inside the method. When calling the method, we'll just do player1 dot change name, and inside parentheses whatever name we wish to change to. So let's say Sam, and if I run this, you see we get nothing. That's because I'm not printing anything out. So I'll just say player1 dot show data, and let's do a before and after. Data, show data, and I'll just create some space here as well. Separator essentially. We have an error, so I forgot to change this. I'll make this self again, and there we go. We get 100, frank, 50 for the first show data. Then we change the name, and then we have our second show data which prints 100, Sam, 50. So that's how you can pass in extra arguments to your methods. So we have one object here, player1. I can create as many objects as I like. So if my game had like a second player, I can do player2 equals player. And now player1 and player2 are two separate objects. I can change properties of player1 and it's not going to affect player2. So let's change the name for player1 to Sam, and let's change player1's health to, let's say, 120, and let's leave player2 with its default values. So if I run my code now, see nothing happens. Once again, I forgot to display player2.show data, player1.show data. I run my code, and there we go. Player1 we have 120, Sam 50. Player2 we have 100, frank, and 50. So these two are separate objects, and changing properties for one does not really affect the other. That's all for this lesson on classes and objects. To recap, an object is composed of properties, which are variables, and behaviors, which are functions or methods. You create an object in Python by first defining a class, and then creating instances of the class. So we create our class using the class keyword, give it a name, we have our properties and our methods. Ensure to have a default parameter, usually called self, in your methods. And then we create our objects by basically calling the class and assigning it to a variable. After we've created our object, we can use its properties, change them, print them, whatever we like, and we can create as many instances of our class as we like. In the last lesson, we checked out how we could create classes and objects in Python. In this lesson, we'll continue with OOP and look at inheritance. The basic idea of inheritance is creating a new class based on a different class. Let's see that in code. So I have my player class here and I've just removed the ammo property. And let's say that our game has a few characters we can play as, and each of those characters have different abilities. So what I'm going to do now is I'm going to create a new class. Let's call this Knight. And to inherit from our player class, I just need to put in some parentheses and say player in the parentheses. Now our Knight class is inheriting all of the properties and behaviors of the player class. For now, I'll just say pass. Pass just basically means we don't want to define anything for this class at this point in time. And then I'm going to create an object of the Knight class. So let's say k equals Knight. So that's an object of the Knight class. And now I'll just print k dot health. And I'll also run the walk function from Knight. Notice that the Knight class doesn't really have anything defined for it, it's empty. So if I go ahead and run this now, stop python hello.py, you see we get 100 and walking. So even though the Knight class is empty, we still get 100 in walking, and the reason for that is because the Knight class is inheriting all of its properties and behaviors from the player class as we have defined here. So all of the properties and behaviors that are in the player class are available in the Knight class. So let's create an object of the player class as well. So I'll just say p equals player, and if I print p.health and p.walk, you see we get the same thing. Let's change this a bit so that it's easier to identify which is the player and which is the Knight. So I'll just say Knight here, and I'll say player. And for the walk method, for my player class, I'll just say player walking, right? So if I run this, you see we get Knight 100, player walking, player 100, player walking. So even though we are running the walk method for the Knight class, we still get player walking because it's really using the method as defined in the player class. What if we wanted to say something else for the Knight class? So what we do is we'd override the technical term for this. We'd override the walk method in the player class. And the way we do that is in our Knight class, I'm just going to say def walk self and print Knight walking. Now if I run this function, you see we get Knight 100, Knight walking, player 100, player walking. So now when we call the walk function in the Knight class, we get Knight walking, but when we call the walk function in the player class, we get player walking. What if we wanna override one of these properties here? Well, we can do it the same way. So I can say health equals 120, and if I run this, you can see knight has a health of 120 while player still has a health of 100. By the way, the class that we are inheriting from, in this case player, is called the base or parent class, while the class that is inheriting, in this case the knight, we usually refer to it as the sub or the child class. So in this case, player is our base class or parent class, and knight is our subclass or child class. Now let's say we wanted to run the walk method from the player class before we printed this knight walking. In this specific case, it might not make sense, but you may have cases where there's something that happens in the parent classes method that you wish to do before you actually do something else in the child class. So let's see how we do that. All I have to do is in my knight class, before knight walking, I'm going to put in a new line and say super parentheses dot walk parentheses. Super basically calls the parent class, and walk is the method we want to execute from the parent class. I'm also going to add in a dash between my knight and player information on the console, just so there's some separation. And now if I run this, you see we get knight 120, player walking, knight walking, and then we have player 100, player walking. So once again, essentially what's happening is when we call super, it basically references our parent object, and we are calling the walk method from our parent object. So in this case, it's basically calling the walk method from our player object. Now this super.walk, you don't have to put it before, you can actually put it after as well, and it will work the same. You can see it's a matter of when you wish to run the method from the base class. Now we have our knight class. Let's say we wanted to create another character for our game. So I'll just say class, let's call this vampire, and it inherits from our player class. And for a vampire, we'll just add a new method for bite, right? And we'll just say vampire biting. And what I'll do is I'll just create an object for our vampire class. So that's v equals vampire, and we'll print the vampire's health, v.health, and we'll run the walk method and the bite method. Okay, just clean this up a bit so that it prints nicer on the console. Okay, if I run my code now, you see we get knight 120, knight walking, player walking. So this is from the call to super. And then we have our vampire 100, player walking, because the vampire class is not overriding the walk method from the player class. Vampire biting, so that's from the method we defined in the vampire class. And then player 100, player walking, so that's from the player class. Now I can also define new methods in the knight class as well as new properties. There is no limitation on that. So if let's say the knight wanted a new behavior for, let's say, swing sword, that's absolutely fine as well. Swinging sword, and I can say k dot swing sword here, and you can see that works as well. No limitation on that. Cool. So that's all for inheritance. In this lesson, we'll be looking at a few ways of executing Python code. So the first is using a Python script. I have my hello.py file open here, and it just says print hello world. If I go to command prompt and say python hello.py, enter, see we get hello world. Another thing we can do is if I just type in Python and hit enter, we actually get the Python interpreter. So you see this Python, the version number, some extra text, and then these three greater than signs. If I type in print hello world, enter, you see we get hello world. I can do calculations in here as well. So 2 plus 2 times, or 2 plus 3 times 5, see we get 17. And I'll do an if statement as well. So if 1 equals 1, print, let's just say true, and else print false. And if I hit enter, you see we got true. Now this indentation here is important. I just used the space character on my keyboard, the space key on my keyboard, but this is important so that Python understands that this line is actually a part of the if statement. If I want to get out of the interpreter now, all I have to do is just type in exit with open close parentheses, and if I hit enter, we are back to our normal command prompt. So that's another way of executing our Python code. Next, I'm going to go to start and scroll down to my Python folder, and if I open that, you see we get this idle thing here. So if I open that program up, we get something similar to command prompt but in a different color and window. So I can actually type in my Python code in this as well. So if I just say print hello world, you see we got hello world, 2 plus 2, and so on. This is a similar experience to command prompt but in a different window. What I can also do is go to file, new file, and now this is similar to VS Code. I can type in my code just like we do in VS Code, save the file as a .py file. I'll just say b.py, save. And now if I go to run up here in this window and say run module, you see the file is executed. We get b.py and hello world. So you can also use this idle program to create Python scripts and execute them directly from this window as well. And we have our script on the desktop as well. So idle is an example of an integrated development environment, or IDE, and it's basically a program that's been made to help you write Python code. Now the final method I'm going to show you is using Jupyter Lab. So if I just go to Google and type in Jupyter Lab, we get this link to jupyter.org. So I'll just select that one. And we have two programs here, Jupyter Lab and Jupyter Notebook. This is the older program and Jupyter Lab is the newer one. It just has a few more features that can be quite useful. So you can go with whichever one you like. I personally prefer Jupyter Lab, so I'll just go with that. I'll select this install Jupyter Lab button and I'll copy the pip command here. I'll go to my command prompt and paste it to install Jupyter Lab. Give it a second, and once it's done, we can use Jupyter Lab. The way we do that is in command prompt or terminal. I'm just going to say Jupyter with a Y. So Jupyter space lab, and if I hit enter, it should open up in our browser. What I can do now is under notebook here, I'll just select this Python 3. And now we get something like this. So in this code cell here, I'll just say print hello world. And if I click this play button or just hit shift enter on my keyboard, that executes the code in this cell. So you see we got hello world. The cool thing about Jupyter Lab is we have these code cells here, and I can put in any bit of Python code I like in these code cells and execute them. The main benefit of this is, let's say I have a code cell here that just imports math, and then down here I can do some calculation. Let's say a equals 2 plus 2. In a different code cell, I'll say b equals a plus 2, and down here I'll say a plus equals, so that's a equals a plus 5. Okay, and if I run these, so you can see I executed the first code cell that really does not run the other code cells. So that gives me a little more control on which parts of my Python code I wish to execute. Now I'll execute the second one and the third one. So now let's just print a and b. And notice that we haven't really executed this a plus equals 5. And I'm going to come down here to this print line and execute that. And we get 4 and 6. Once again, this line here has not been executed yet, so we don't really have to go in order as well. Now what I'll do is I'll execute this a plus equals 5, and I'll execute this print line again, but let's just copy paste it down here so we can see the different values. And finally I'll execute this b equals a plus 2 again, and let's do another print, run that as well, and you can see the values. So in the first instance we got 4 and 6. That's because 2 and 2 makes a 4, and then 4 plus 2 was 6. Then we changed a to 5, and that's why we got 9 and 6. So a was 4, 4 plus 5 is 9, but b remained the same, so we got 9 and 6. And then finally we executed this line again, so that was a was 9 plus 2, you get an 11. So really this with this you can mix and match parts of Python code, and you don't have to execute it sequentially or in order. You can execute it in any order you like, which really helps with testing. In this example I have written one line per code cell, but you can actually have multiple lines per code cell. So I can do that, print b, print a, whatever, and that works fine as well. You can see. Welcome to the final stretch of this Python for Complete Beginners course. We have covered all the basic concepts a beginner to programming and Python would need to know to get started on their coding journey. Now it's practice time. There are a lot of things you can explore and learn moving forward. However, I would suggest taking some time off to write some programs before continuing with more tutorials and lessons. Good programmers write lots of code. It'll help you get to grips with the concepts we have covered, retain the syntax of Python, and develop your technical thinking skills. To help you with this, we'll try to build a simple application in the next few videos, which I'll follow with a few coding problems for you to solve using Python. I would suggest completing these at the minimum before diving deeper into Python and the different types of programming. Feel free to work on simple projects that interest you as well. The application we'll be building is a simple calculator. So I'll just demo the final program here. So you can see it says to enter a number, so I'll just enter 5, second number 3, and then it tells us to enter an operator, so plus minus, multiplication and division, or -1 to exit. So I'll just say plus, and it says 5 plus 3 equals 8. Then it asks for another number, so I'll just say 6, 5. I'll do subtraction this time, and we get 6 minus 5 equals 1. So this time I'll just give it two random numbers and say -1 for the operator, and you can see it says thanks for using my Albit calculator and exits. So this is the final program we'll be building, but we won't jump into everything at once. What we'll do is we'll start slow and take it a step at a time. To start off, our calculator will be very simple. So if I run my script here, you can see that it asks me for a number. I'll just say 5. It asks for another number. I'll say 2, and it just gives me the addition, subtraction, multiplication, and division, all 4. So this is the first challenge. Take some time off, maybe a few days, and try to code this up in Python. If you get stuck, don't worry, just stick through it. Google is your friend. Give it some time and see how it goes. If maybe after a week you're not able to solve it, then do not be discouraged. Just watch my video and keep moving forward with the next exercise. Now it's highly likely that you may have forgotten the syntax of the code that we've been seeing so far. So to kind of help you out with that, I have made a cheat sheet for you guys. So this is available on my Patreon, linked in the description below. However, if you cannot get the cheat sheet, you can refer the previous videos that I've made so far, and also Google to recap on everything we have covered so far. So the cheat sheet is just a basic 4-page document with code examples of everything we've covered so far. So you can see output, we have these print examples. Input, we have some input examples, how to create variables and collections, the syntax for the if statement, while loops, for loops, how to create functions, how to create classes and objects, and so on. The main idea with this is it's likely that you would have forgotten the syntax of everything we've covered so far, how everything is written in Python. So this is just a helpful reminder on how to write Python code for the different things that we have done so far. So once again, you can get this through my Patreon, link in the description below. And with that, give the challenge a go, and I'll see you in the next video for the solution to this. In this video, we are going to be looking at the solution to the first calculator challenge. So in the previous video, I gave you a challenge to create a very basic calculator that just asks a user for two numbers and adds, subtracts, multiplies, and divides it. So we'll see how we can do that in Python. Just to go over the calculator once again, I'm going to run my script. It asks us to enter a number. Let's say 5, enter a second number, let's say 3, and it gives us 5 plus 3, 8, 5 minus 3, 2, 5 times 3, 15, and 5 divided by 3, 1.6667. So in this video, we'll just see how we can code this up in Python. So I'll open up a new file, and let's just save it as calc solution1.py. And now first thing we want to do is ask the user for two numbers. So let's just do that. So I'll just say first num equals input, enter first number, and now this is going to come in as a string, so we need to convert it either to an integer or a float. I'll do float just so we can handle decimal numbers as well. I'll do the same thing for the second number. So enter second number, and there we go. Now that we have our two numbers and converted into floats, we can do the for calculations. So I'll just say sum equals first num plus second num. I'll say sub for subtract, or we can say diff for difference. First num minus second num. Prod for product, so that's first number times second number, and let's just call it div for division, first number divided by second number. Okay, cool. And let's print this out. So I'll just say first num, then comma, we'll add a plus here, second num equals, and I'll say sum, and I'll just copy this over for the others. So I'll change the operators and the variables for the actual calculation. This is div. Okay, cool. So let's run this and see the result. The file is called calcsolution1.py. So enter, and it says enter first number, enter second number, and you see we get 5 plus 2 is 7, 5 minus 2 is 3, 5 times 2 is 10, and 5 divided by 2 is 2.5. So this was your first challenge. I hope you gave that a go. Don't worry if you struggled with it a bit. If you managed to complete it, awesome. If you struggled with it a bit, it'll eventually click. So don't worry about it too much. So that's the first challenge done. Now we'll expand on it a little to add some more functionality to our calculator. So the second challenge is to create functions for adding, subtracting, multiplying and dividing. So all you have to do is create 4 functions, each taking in 2 numbers as parameters, and then one of them will add the 2 numbers, another will return the difference, third will return the product, and fourth will just divide the 2 numbers and return the result. And then modify the code to basically use the 4 functions. So the program will basically do the same thing, but in the backend code side you'll actually be using functions to do these calculations. So take some time off, maybe a few days, give it a go and see how it goes. All the best and happy coding. Welcome to another video on the Python calculator challenge. In this video we'll be solving the problem I mentioned in the last video, which was to convert these 4 calculations into functions. So the program is going to work in the same way. We'll enter 2 numbers and we'll get the sum, difference, product and the division of the 2 numbers. But on the code side we have to create 4 functions that are going to add 2 numbers, subtract, multiply and divide. So let's do that now. We'll first create a function to add 2 numbers. So we'll just say def add, and we'll say our numbers are a and b, and we'll just return a plus b. Next we have the difference, so we'll just say subtract a and b, return a minus b. We'll say def multiply a and b, return a times b, and def divide a and b, return a divide by b. Cool. Now we have to change our code here to basically use these functions. So what I'll do is I'll just say add first num and second num for our sum. It's first num and second num. We're going to use the subtract function next to get the difference, and then we're going to use the multiply function to get the product, and finally we're going to use the divide function. So that's divide first num and second num. Awesome. If I run my program now, enter, it asks us for a number, second number, and you can see we get the same result. Basically 5 plus 2 is 7, 5 minus 2 is 3, 5 times 2 is 10, and 5 divided by 2 is 2.5. The next challenge is actually to modify the code so that it asks for a third input, the operator. So that's going to be plus, minus, times, or divide, and then performs the calculation based on the operator. So let's just quickly see what that will look like. So basically the program is going to ask you for a first number, let's say 5. It's going to ask you for a second number, 3, and then it's going to ask you for an operator. And you can see I've provided examples of what it should be, just so the user has some idea. And let's say plus, I hit enter, and it says 5 plus 3 is 8. It does not show me the result of the other calculations, it just does the addition because that's what I asked for. Let's run the program again. Let's say 8 and 2, and let's say this time we want to multiply, and you can see 8 times 2 equals 16. So that's the challenge for this video. Take some time off, maybe a few days, and give it a go and see how it goes. Happy coding! The third challenge was to modify our program to accommodate an operator. So let's just see a sample of what that looks like. Our program asks us for a number, so I'll just say 5, another number 3, and then we get a prompt for an operator, and you see I have a few samples here. So we'll just say plus, and the program shows us 5 plus 3 is 8. If I run the code again, enter first number, enter second number, let's say multiply, and we get 4 times 6 equals 24. Let's see how this is done. So I have the solution from the previous challenge open here, and what we want to do is first prompt the user for an operator. So I'll just do that here. Let's say op for operator equals input, enter an operator, and I'll just give an example of what that might look like. So enter an operator, that, and we can just put colon here. Now these are not numbers, so I'll be leaving them as a string, and what we can do now is just use an if statement to check what our operator is, and based on the operator do our calculation. So I'll say if op equals a plus, then we wanna sum, right? So sum equals add first num and second num, and then elif op equals a minus, then we want to subtract, elif op equals multiply, and finally for division. There we go. We also have to change the variable name to be the same, so I'll just do that. I'll use res for result, and res, and res, and then down here I'll just say first num operator, second num equals res. The reason I changed this to operator is because we don't know what it could be, so we just print out whatever the user entered. And the reason we needed to change all the variables to the same variable name was basically because we don't really know what the user will enter for the operator, so we can't really say which one of these we are going to be printing. So let's run our code and see the result. So we're going to enter first number, let's say 5, enter second number 3, operator, let's say plus, and we get 5 plus 3 is 8. Let's just run it again. First number 2, second number 3, let's say divide this time, and 2 divided by 3 equals that's I guess 2/3. Cool, so our code's working. The next challenge in this series is to make it so that the program keeps running until the user enters -1 for the operator. So if I run my script here, you can see it says enter an operator plus minus whatever or -1 to exit. I've also moved the operator to be the first thing that the program asks you for. So let's just enter plus, and it says enter first number 5, enter second number 3, and 5 plus 3 equals 8. Once again we get the prompt, so I'll just say divide this time 5 and 2, and we get 5 divided by 2 is 2.5, and we get the prompt again. If I type in -1, it says thanks for using my Albit calculator and exits. So that's your next challenge. Give it a go and see how it goes. Thanks for watching and happy coding. In this video, we're going to be looking at the solution for the challenge in the previous video, which was to keep the program running until the user enters -1 for the operator. So let's just see what that looks like. So it says enter an operator or -1 to exit. I'll say plus, first number 5, second number 3, and we get 5 plus 3 equals 8. Then it asks for an operator again. So I'll just say divide this time 5 and 2, and we get 2.5. And it says enter an operator again, so I'll enter -1 just to exit out of this. And you can see we get thanks for using my Albit calculator, and we get the prompt again. So let's see how we do this in code. I have the solution for challenge 3 open here, and we'll just modify this. So what I'm going to do first is to just move this operator line to the top. If you actually have your cursor on this line and hold down the Alt key on your keyboard, you can use the arrow keys to move this line up or down. And I'll change the prompt here to say enter an operator or -1 to exit. Cool. So now it's asking for an operator, and it's telling us to enter -1 to exit. We ask for the first number, we ask for the second number, we do the calculation, and we present the result. So what we can do here is to just wrap this in a while loop, and what that will do is just basically keep running the program over and over again. So to start with, I'll just say while true. What this will do is it'll run this code infinitely, so like forever. We'll just start off with this and modify it later. And now what's going to happen is we ask for an operator, first number, second number, we do the calculation, and we present the result. Then we ask for another operator and do the calculation, result. Another operator, do the calculation, result. So at the moment our program's working for the most part, but we can't really enter -1 to exit. It just keeps running. So what we want to do is say while OP is not equal to -1. So as long as this is not -1, basically we'll be running the program over and over again. If I run this now, we'll actually get an error. So I'll just do CLS and Python calc solution. you can see we get an error, name OP is not defined. So basically we are getting OP here, but we're using it before we actually get a value, so we get this error. So we need to move this outside of our while loop. Now we'll ask for an operator and then check if that operator is -1. If it's -1, then we won't really run anything here, we'll just come down here. But if it's not -1, then we are going to execute this code. Cool. So let's just run that. This is enter an operator, I'll just say plus, so that's not -1. It says enter first number, let's say 5, second number 3, and we get 5 plus 3 equals 8. But then it didn't really ask for an operator again, it just went to first number. However, the sample I showed you asked for an operator again. So to do that, we actually have to ask for an operator down here. Oops, just copy this line. And I'll just do a /n here, so that there is some space between the result and this line. Now if I run this, you can exit out of the program by pressing Ctrl+C, by the way. And I can say plus, first number, second number, and you see we get the result. Skip a line because of the /n, and it says enter an operator or -1 to exit, and if I enter -1, it exits. The way it's working is the program asks us for an operator, check if it's not -1. If it's not -1, like say if it's plus or something, then it's going to ask us for a number, another number. It's going to do the calculation and it's going to present the result. Then it's going to ask for another operator. If that operator is not -1, then it's going to ask us for a number, second number, calculation, result, and then it's going to ask us for an operator. If it's not -1, once again it's going to run this code. However, if it's -1, then this condition is going to be false, so our while loop will exit and our code will come down here. So at the end of our code, we just had a line that said print, sorry, not print, it said thank you for using Melbit calculator. So we'll just do that, and maybe let's give it a /n as well, just so we have some space between this code and this bit here. Cool. So if I run this now, I can enter plus 5, 3, okay, and let's say -1, and we get thank you for using Melbit calculator. We have one problem. If I just did this, so let's enter 5 or something. If I hit enter, it says enter first number, second number, and you see we get a traceback, basically an error. It says name res is not defined. What happened is we're checking if the operator is -1, we're checking if the operator is plus, minus, multiplication, divide, but what if it's not any of these? Then the user has really made an error because they're only supposed to enter one of these 5 values. So we want to check for that as well, and the way we can do that is to just put an else here. You can say else print invalid operator, please try again, and we can basically ask for the operator once again. Now if I ran this and let's say 5, first number 5, second number 3, you see it says invalid operator, please try again. Ask us for an operator. Let's say I enter something valid plus, and we still get the traceback, still get the error, and the reason is we entered 5, right? So it does all this, comes down here, prints that it's an invalid operator, asks us for an operator again, and then it's going to come down to this line, which is not what we want. Here it's doing the calculation again, so that's not something that we want. So What we want to do is right after we ask for this, we want the program to go back to the top, right? Check if the operator is -1 again and continue here. The way to do that is to put a continue. So what continue will do is, as soon as your code encounters this line, it's going to skip everything after this that's in the while loop and go back to the start of the while loop. It's going to check the condition again. It's going to run the code again. And I'll do something else as well. I'll just remove this /n and put it here, so we get some separation. Okay, so let's do plus, first number 5, second number 2, and it says 5 plus 2 is 7. Let's enter 5 for the operator. First number 6, second number 4. It says invalid operator, please try again, and asks us for an operator. Get proper spacing. Let's say operator is 6. Oops, that's wrong. Okay, we get that again. So let's say plus 6 and 3. And you can see we get 6 plus 3 equals 9, and the code continues as normal. So I'll just say minus. And there you go. Thanks for watching and happy coding. In this video, we will be rewriting some of the code for our calculator from the previous video. This process is called refactoring, and basically the idea is to rewrite some code that we have already written to make it better. With that, let's get started. Now this is fine for now, but one thing that I don't like is if we enter an invalid operator, it still asks us for the first and second number. We could probably improve this to say that if it's not valid, then don't ask us for first and second number. Go straight to the invalid operator message. So what we can do is, before we ask for this first and second num, you can just put this part of the code up here. So what we want to do is we say if operator not equal to plus and operator not equal to minus and operator not equal to times and operator not equal to divide and operator -1, although we don't really have to check this because this is being checked in the while loop here, so we can skip this part. We want to say this, else we do all these calculations. So I'll just do that, and I'll remove the else down here. This in as well. Okay. So essentially, if the operator is not -1, we check if it is a plus, minus, multiply, divide. If it's not, we say invalid operator, then ask for another one. And if it is one of these, then we just ask for 2 numbers based on the operator, do the calculation and print the result, then ask for another operator and continue until the user enters -1, in which case we exit. If I run my code, let's enter an operator. Let's enter 5 for the operator. We get invalid operator, please try again. Let's enter 6, once again invalid, so let's enter plus. First number 3, second number 2, we got 3 plus 2 is 5. Let's enter an invalid operator, same thing, we got a message, so let's enter divide. 5 to 2.5, and it keeps going until I enter -1, at which point it says thank you for using Melbit calculator. Now this is great, it works. Now we don't really need this continue line because since this part is in an else statement, after this if is executed, the code is already going to go to the while loop by itself. So we don't really need this continue anymore. Yep, so essentially it's going to check if it's a valid operator. If it's not, it's going to tell us that it's invalid and to enter an operator again. And now since this if executed, all this is going to be skipped, the else part, and it's going to go back to checking if the operator is -1. Another thing we can do is we can actually remove this line from here and here. Since they are the same, since this and this line is the same, we can actually get rid of it from the if statement and just put it down here outside of the if. The reason I did that is because this line is part of both the if and the else condition. Since it appears in both, instead of writing it twice, I can just put it out. So now if it's an invalid operator, it's going to print invalid operator, please try again, and then it's going to come down here asking for another operator, back to the while loop. If we enter a valid operator, so this is false, so it's going to come to the else, it's going to ask for two numbers, calculation, result, and it's going to ask for an operator, at which point it's going to check if the operator is valid. Cool, so let's just see that. Let's say +3, 5, we get 8, and let's just say 6. It says invalid operator, please try again. 5, invalid operator, plus first number 9 to 11, -1, exit. Now this works. One small improvement we can do is we can actually just comment out this if and rewrite it as if op in as a list supply all of our operators. So I can say that minus multiply and divide. Put a line here just so it's easier to see. And now this will basically check if this operator is in this list. Now we want to say invalid operator if it is not in this list. So I'll just say not here. If operator not in the list, then you want to say invalid operator. Otherwise, you want to run this code. So this is fine, but to take it one step further, what I'll do is I'll just create a list up here to say valid operators, and I'll put these operators in there, right? And then I can say if operator not in valid operators. And there's just a slightly better way of structuring our code. Now whenever we add more operators into our program, let's say modulus or something else that you wish to add later on, you can just add it to this list, and our code is going to check for the operator's validity by itself, since we are using the list to check if the operator is valid here. So that completes our simple calculator. Feel free to add further features or make improvements as you see fit. We have one more video in this series where I'll show you how to structure this program, and that'll be the end of the series. I have my simple calculator solution from the previous video open here, and let's say we wish to import one of these functions in a different Python script or file. So how would we do that? I have another Python file here, hello.py, and what I'll do in here is I'll just say from calc soln, that's short for solution, import add. So calc solution is the name of my file where the add function is located, and add is just a function name. And down here I'll just say print this is a message from the hello file. Cool, so let's run this file, python hello.py. Now when I run this program, what we expect to see is just this line, right? This is a message from the hello file, nothing else. But you'll see that when I run my program, I actually get enter an operator or -1 to exit. Okay, so if I did plus, it says enter first number, enter second number, and it's giving me the result and asking me to enter an operator again. So it's actually running the contents of the calc solution file. And if I do -1, you see it says thank you for using Melbit calculator, and then this is a message from the hello file. So it did print this message out, but it printed it right at the end here. If I actually move this before the import, run, you see we get the message, and then we get the code from our calculator solution executing. So what's going on? Well, in simple words, basically Python is running all the code in calc solution when we are doing the import. So how can we prevent this? Well, I'm going to go to my calc solution file, and right at the bottom I'm going to say if __name __ double equals, and then in quotation marks __ main __. And then if this condition is true, I want to run a function called main. Okay, so if name equals main, I want to run a function called main. And let's create the main function. So I'll just say def main, and in this function I'm going to put all of my calculator code, all of the code that makes the calculator work. So the entire operator part, the calculation part, and the result part. Now if I go back to my command prompt and I run the hello file again, you'll see that we just get the message. This is a message from the hello file, and the calculator does not really execute. If I move the message up, same thing, the calculator does not execute. But if I specifically ran the calc solution file, it says entire operator 5 3 5 plus 3 is equals 8, so it's a minus 6 3 and 3 -1 to exit. Thank you for using Melbit calculator. So when I ran the calc solution file, it basically executed our calculator. This line just checks to see if this is the file that's been executed, right? So it's essentially checking if we are running Python with the calc solution file. If we are, then it's running the main function, which is what runs our calculator. But if it's not, so if we are not running calc solution directly, then this condition is false and the main function is not executed, which is why we don't really get the calculator. So whenever we run the file directly, the condition is true and main is executed, which runs our calculator. Whenever we import the file, this condition becomes false, so this function is never run, which is why our calculator is not executed. So that's all for this video. We have reached the end of this Python for Beginners series. The next video will be the final in this series, and I'll just be going over 7 problems to continue practicing with, a Python cheat sheet, and a written version of this entire series. Welcome to the final video in this Python for Beginners series. In this video, I'll be telling you what to continue with after completing the calculator challenge. So before you move on to anything else, it's important that you practice the skills you have learned using some coding challenges. So you can work on a project of your own if you wish. However, if you don't have any ideas, I have 7 problems that you can work on. So what we're going to do is on Google, I'm just going to type in project Euler or Euler, I'm not really sure how it's pronounced, but it's EULAR, and we're just going to go to this website projecteuler.net, and we're going to go over to the archives. So I would recommend doing the first 7 problems here. Initially when I started programming, it was a bit of a struggle, but doing these 7 problems actually made programming click for me, and I started doing really well after solving these. So it's probably not going to be easy. It may take a while for you to figure how these are solved, but stick with it and keep going, and eventually you'll figure it out. So if you do get stuck, and don't be afraid to look up stuff online. However, don't look for solutions. For instance, if we look at this problem here, it says if we list all the natural numbers below 10 that are multiples of 3 and 5, we get whatever. If you get stuck on this problem, looking at the final solution is not a good idea. You won't really learn anything. You'll just end up copy pasting the solution. So what I mean by you can look up stuff online is, let's say you don't know what multiples of 3 and 5 are, then you can Google like multiples of 3, or how to figure out a multiple of a number, things like that. Similarly, if you go to the second one, it talks about the Fibonacci numbers, and this one gives an example. But if, let's say, you still don't understand what it means, then you can look up a tutorial on what Fibonacci numbers actually are. So yeah, you can use Google to figure stuff out, but don't use it to get solutions to the problems. Now, once you write your program and you get your solution, so your final solution is actually going to be a number. So this one just wants the sum of all multiples of 3 and 5 below 1000. So it's going to be a number. So it's not really going to be the code. You can register to this site. They don't really spam you with anything. Really, I haven't received anything from these guys like ever. So you can just register. And once you do, you'll have the option to submit your solution, your answer, and it'll tell you if you're correct or not. So you won't really be giving them code, you'll just give them the final number and it'll just tell you if it's correct or incorrect. You can do that. So go through the first 7. You can do more if you like, but first 7 should be enough practice for everything we've covered so far. And after that, you can look at what you'd like to do next. So if you're into web dev, you can look at Django, or Flask, or let's say HTML, CSS, JavaScript. If you're into data analysis, then Pandas, Matplotlib. If you're into data science, then maybe scikit-learn, and so on. So after you have done these 7 problems, then you can look into a specific niche and start learning the relevant content there. I've made a cheat sheet, so I had mentioned this in an earlier video, but this is a simple cheat sheet. It's a quick reference for everything we've covered. So how to display stuff on the console, user input, creating variables, how to write if statements, while loops and for loops, and so on. If you want this, you can get it on my Patreon, link in the description below and also the first comment. And if you want a written version of this tutorial, it should be up on my website, melbitmedia.com. Now this is a work in progress, so it's not there right now, but it should be by the time you view this video. So melbitmedia.com, also in the description and first comment. And that's all from me now. The next set of tutorials will be on Pandas, so I will be focusing on data science and data analysis on this channel, and if you're interested in that, you can have a look. Like, comment and subscribe. Thanks for watching and happy coding.